graph these linear functions by making a table. But here's what you want to make sure that you look for first of all. Before you start to make your table, to find the values, I want you to make sure that your equation is solved for y. Or in other words, y is all by itself. Because when y is all by itself, then we have the function rule on the other side. So we want the y alone. And then because x is the control, the independent variable, the input variable, number 2, we're going to pick values for x to put into the function rule, because remember on the other side is going to be that function rule where x is involved. And when we put values in for that x, that'll help us get the y's that we need. So pick values for x to input into the function to get your y. Well then when we have an x value and along with it we have a y value that goes with it, what do we call that? We have an x value and a y value that goes with it. What do we call that? And a point, also known as what's the mathematical term for ordered pair? Graph the ordered pair from the table. In other words, the x and the y value that go together, they're the coordinates of a point called an ordered pair. And then use a straight edge to draw the line. We should always get a line. Something went wrong. If it's a linear function, you graph your points and you don't have a straight line. And today I can tell you all of ours are going to be lines. They should all turn out to be lined up. Okay, here's our first one we're going to practice. Number 1. Y equals negative x plus 2. What's our first step? What's it say? What's it say up there? What's step 1?
Solve for y.
Solve for y. Do we get to skip step 1 or do we have to do it?
Skip it.
Is the equation solved for y already?
Yes, it is.
Yeah, it's already solved for y, isn't it? So if it's already solved for y, then what's on the other side is what we call our function rule. So we're going to put that in our table, in our work column. Our function rule goes in our work column. Okay. I'm always going to pick, for a while anyway here, I'm going to pick those x values for you. I'm going to give you the x values that are going to give you a good graph. And so for this particular linear function, we're going to use negative 2, negative 1, 0, 1, 2. So write those down. Use your x values filled in. Because then the next thing we're going to do is we're going to substitute into that function rule and we're going to get our y value. Now, be really careful. I think this is where some of you have gotten in trouble before with doing tables. That negative sign that's in front of that x, it's not part of the x. It's in front of it. It always has to come along. So that negative sign is always going to be there. It starts it out every single time. Now, we're going to substitute in our x value that we have for that particular row. So let's start with negative 2. And then the rest of the rule says add 2 to that. So we're substituting into our function rule negative x plus 2. The negative sign is not part of the x. So we have to have it there. That's what I have first. Substitute in the negative 2. That's what I have in blue. Add 2. Riley?
Did we already do something like this?
We did already do something like this, yes. So this should look familiar. Absolutely. So this says right here, whenever we have a negative 2 like that, that really says this. Remember, the negative sign can also be read as the opposite of. So that's really asking us, what is the opposite of negative 2?
2.
2. So that first part of it becomes just a 2. And 2 plus 2 is 4. So there's our y value.
4.
So what's our ordered pair?
4.
Negative 2, 4. Okay, that's one of our points on the graph. Rose?
What happened to that red negative?
Okay, so you're talking about this part right here.
Wouldn't it be just the other one? Wouldn't that go with the four? Why did you just say negative?
Okay, so you're not questioning the work, you're questioning the ordered pair.
like, the negative x thing,
Mhm.
you brought the negative sign down, aren't you supposed to put that with the 4?
Nope, that came with, that was with the -2, it's with the x. So it's really saying you're gonna take the opposite of x. So here's our negative, our opposite sign. We put -2 in for our x because that's what we were supposed to put in. And then we said, okay, what is the opposite of -2? It is +2. So that took care of our that negative sign. It went away now. So now we have a +2 plus that other 2, and that's how we get our 4. So we don't bring that negative sign over here to the 4, no. Emerson.
Only when it has a bars between it, is that -1 and 2, -1.
That's right. When you have absolute value, then we have to think a little bit differently. Okay? Okay, so let's go put that point on our graph. -2, +4. And now we're ready to get another ordered pair. So again, I've already put that negative sign there from the negative x. Now I just need to substitute in my x value, which is -1, and add the 2. So what's the opposite of -1? +1. So now we have +1 plus 2, and that is 3. So our next ordered pair is what?
-1 +3.
-1, +3. So let's go put that point on our graph now. Okay, now we're going to substitute 0 in. Here's my negative sign for the function rule. I put a 0 behind it. I add 2. This is really, don't be confused by this, it's okay. We know that 0 is neither positive or negative, but 0 does have an opposite, it's itself. So the opposite of 0 is? 0. And 0 plus 2 is? 2. So we now have ordered pair 0, 2. By now we should be seeing that pattern. What do you think the next one's going to be? What do you think the next y value is going to be? 1. And then the next one?
0.
Probably 0. Okay, now we're putting in positive x values, but remember that negative sign still is along. It's still part of our function rule. So we're substituting in that +1 into our function rule. And we get, what is the opposite of 1? No, what's the opposite of 1? -1. So this just kind of stays what it looks like. It's -1. -1 plus 2. The opposite of 1 is -1. And -1 plus 2 is 1, like we wanted it to be. So ordered pair, 1, 1. And then we'll do our last one here. So now we're going to substitute a 2 in. This says, what's the opposite of 2? -2. What's -2 plus 2?
0.
0. Number plus its opposite is 0. So now we have ordered pair 2, 0. We go back and grab our x. That's the x value of our ordered pair. What did we get for y? And now we graph that point. 2, 0. Okay, take your rulers and draw a nice straight line going all the way through the graph. Not just through those points, but all the way through the graph, because what we do is we put arrows at both ends of it. You don't have any rulers? Well, that would be good if you did, huh? Yeah, I just told you might have to make your own straight edges, but I said when you're in here, you can use mine. So maybe I should get you some. So all the way through the graph, arrows at both ends. So going through your points, my line's a little bit off, but you do a better job than I did. All the way through the graph. Arrows at both ends, because linear function actually has an infinite number of points. It has so many points we couldn't even begin to graph them all. We just picked 5 x values so we could get 5 points to help us make a graph. Okay, put the ruler back down. It is not a plaything now. Put it down. You're done drawing your line. Set it aside. Let it rest. Keep your germs off of it. Okay. Anybody have questions about this one? So the trickiest thing is when there's this negative sign right here, you have to keep that. It's part of the problem. It doesn't replace the negative of an x value. Okay? You have to treat it more like saying the opposite of. Okay, let's go to the back side and see what we have back here. Y plus 4 equals 3x. We need to do step 1.
Yes.
Yes, y is not by itself. So what are we going to do?
Subtract 4.
Subtract 4. 4 is being added to y. So we need to subtract it. So now y is alone because y plus 4 take away 4 is just y. 3x and take away 4. Can we combine those? Are they like terms? No, they're not like terms. The 3 has an x behind it, so those are x's. That 4 is just the number 4, no x with it. So we have to write it like this. We just say, you know what? But what we're going to do is we are going to change that to add the opposite, because chances are we're going to have to work with some negative values in there. So let's just change that to plus a negative 4. So what's our function rule for this one?
3x plus
3x plus negative 4 is our function rule. So that's the part that's going to come down here into our table that we're going to substitute into. And notice I've picked the x values here for us. I said we're going to go with negative 1, 0, 1, 2, and 3. So we're going to substitute in. Now, remember, parentheses, the way I'm putting it in right now means multiplication, doesn't it? And 3 next to x means multiplication. So I'm substituting in my negative 1 for the x. What is 3 times negative 1?
Negative 3.
Negative 3. And then plus that negative 4.
Negative.
And what's that equal? That's
Negative.
negative 3 plus negative 4. So you borrowed $3 from somebody, now you borrowed another $4. How much do you owe them?
Or negative 7.
It'd be negative 7. Yeah. So we have ordered pair,
Negative 1, negative 7.
negative 1, negative 7. We'll put that on your graph. Negative 1, negative 7. 1 to the left of the origin, 7 down. And now we'll go in our next one. So 3, this time we're substituting in 0. And completing the rest of our function rule. 3 times 0 is?
0.
0. What's 0 plus negative 4 class?
Negative 4.
Okay, I'm going to have to tell Isaac he can't answer anymore for a little bit, so the rest of you can exercise your vocal cords. So Isaac, give your vocal cords a little rest for a little bit, okay? Thanks. You have been a great participant. Okay, so we get 0 and negative 4. Let's go graph that one now. We don't go left or right because it's 0. We just go straight down 4 units and put our second point. And now we're going to substitute in 1. Three times 1? 3. So now we have 3 plus negative 4. Mia, what do we have?
Negative 7.
Here's the positive 3 and plus a negative 4. Stefan? It would be negative 1. Okay. So it's like it's 3 above 0, the temperature drops 4 degrees. Thank goodness we're out of those days for a while anyway, and it's 1 below now. So our ordered pair is 1, -1. So now we'll put that point on the graph. And again, they should be lining up in a linear pattern, shouldn't they? Okay, you go ahead and finish the other two, see what you get. Let's find out what you get for ordered pairs. Okay, and because we're graphing linear functions, we should be saying to ourselves, yeah, I need to have a pattern going on in my x's, and I need to have a pattern going on in my y's. What's the pattern that's going on in the x's? What's the constant change in x in this one? Isaac?
You're adding 1.
You're adding 1. Sorry, the rest of you got your hand up too late. I thought Isaac was going to be the one to dance for me again. So x is changing by a +1. What's the y changing by, Josh?
Adding 3.
By adding 3. Yeah, so there's our patterns that we were looking for yesterday in the tables, and make sure that it was a linear function. And so we should see a pattern develop on these. So now we'll draw our line going through our points with arrows at both ends to show that that line really goes on forever and ever in both directions, has an infinite number of points on it. We only graphed 5 of them to get a graph, a good picture of it. Okay, so any questions about this one? Okay, we're going to do one more together because I don't want to hear tomorrow that it didn't go well because you didn't know what to do. Ooh, I wonder what's going to happen in this one. We need to do step 1.
Yes.
Yeah, we got to get y alone. So what are we going to do to get y alone? Emerson? We had to divide every piece by -3, but before we do that, I see a subtraction in this problem. What do you think I want to do? Add the opposite. Yeah, I want to change it to add the opposite. So that's the first thing I'm going to do. I'm going to change it to plus a -3 because when we divide, it'll go better, especially because we're going to divide by a negative number besides. So now we'll do what Emerson said. She says, let's divide every piece by -3. So now a -3 divided by a -3, those actually cancel out, so we do have the y left alone. What's 6x divided by -3? Josh? -2. 6 divided by 3 is 2. A positive divided by a negative is a negative, and those are x's. So -2x plus, what's a -3 divided by -3? Plus? 1. Okay. So Dakota, what's our function rule?
Y equals negative.
No, what's our function rule?
Negative 2x plus 1.
Thank you. Only the part that y is set equal to is our actual function rule. So -2x plus 1 is what's going to come down to our table. And we'll substitute into that. So we'll start with -2. Sub in -4, add 1. What is -2 times -4? Isaac?
Positive.
Positive 8. Ian, what's 8 plus 1?
9.
9. Thank you. Okay, so we have ordered pair what, Ian?
Negative
-4,
4, 9.
9. Okay. So let's go put that ordered pair on our graph. Okay, and now let's substitute in our -2. So we have a -2 that's going to get multiplied times a -2. -2 times -2, class?
4.
4. That was a weak class. 4 plus 1?
5.
5. Okay, so we have ordered pair, -2, 5. Okay. I'm going to give you a little break. If there's a constant change in x, if and only if there's a constant change in x, this is the only time you can get away with this. We already know that we're doing linear functions. So if there's a constant change in x going on, after you've done 3 of the y's, you can decide what is the constant change that's happening in y, and you can not show the work for the last 2 points. So is there a constant change going on in x, first of all?
Yes.
What's happening?
You're adding 2.
The x's are going up by 2 every time. Every time it's going up by 2. Is that right? Does it keep going though? You got to make sure it does. Okay, so it goes up by 2 every time. If they go up by 2 every time, I'm going to let you do 3 of them you show the word for, and then you can say, okay, here's what's happening to the y's, because I saw it happen a couple of times, I'm pretty sure. So -2, substitute in our 0, add our 1. -2 times 0?
0.
0 plus 1?
1.
Okay, so ordered pair 0, 1. Okay, what's that constant change in y, Malcolm? What's going on? What's happening in the y's? So we can quit showing work. After 3, everyone should quit showing work if you can know what the pattern is in the y's, the constant change. What's happening? You know? Or do you want to pass the baton to Cameron? It's going down by 4s. Oh, well, if it's going down by 4s, that would mean then that the next ordered pair is 1 take away 4. Basically, that's all we got to do is 1 take away 4. What is that?
-3.
Because that was the last one. So -3. It's going down by 4 again. -3 take away 4.
-7.
-7. But make sure you put the right x values with them. Go back over and look and see what was the x value that I needed to do. Now we can graph. I kind of quit graphing points tonight. Let's get all 5 of our points graphed. And on the graph, you should even see that gap of going down 4. You should be able to see that every time we go up by 2 on the x, as we're going this way, as we go over by 2, it's going down by 4. We should be able to see that happening on the graph also. Draw your line once you have your 5 points. Oh, that's not a good line at all. Let's try it again. Arrows at both ends. Isaac.
Would it always be like a straight line like that?
Yep, if we're doing linear functions, it better be. If it doesn't turn out to be a straight line, then there's a problem. Our line points don't line up like that.